Thanks for having me. Today I was going to talk a little bit about research my group has been doing over the past several years to look at privacy issues in mobile apps. So based on this research, a common question that I get from everyday end users is, what can I do to control my privacy when I use mobile apps? And the answer is easy. I tell them what I do. Instrument the permission-protected APIs in Android, disassemble the app binaries, and then perform deep packet inspection to see where the data is flowing. It's simple. While that's obviously a ridiculous answer, I contend that it's not really that much more ridiculous than what users are actually supposed to do. And that is, we have this framework called notice and consent in the US. And basically what that means is read privacy policies. So say I want to install a new app on my Android device, I go to the Play Store, and just to pick on one app throughout this talk. I actually, when I put the slide deck together, I decided I'd pick up whatever app was #1 in the free apps. It was Musical.ly. So we're going to install Musical.ly. We want to know about the privacy practices of the Musical.ly app. So we need to know to scroll all the way to the bottom and then click the link for the privacy policy. And of course, we get this very simple to read privacy policy. And read it we will. This privacy policy is about 5,600 words. It's written at more than a 10th grade reading level. And so it would take the average person over 20 minutes to read. Now, imagine if we're going to say comparison shop and compare multiple apps. This could be a lengthy endeavor. But this isn't anything new. So there was a study that colleagues of mine did about 10 years ago where they looked at the privacy policies associated with the websites that people actually visit, and they calculated that to read the privacy policies that you go to on average would take about 200 hours a year. So basically another job. And given the past 10 years, I don't think that this burden has probably gotten any less. It's probably gotten much more. So what do we look for when we look at privacy policies? So one thing that people are concerned with is what data is going to be received by various third parties. And ostensibly, the privacy policy will answer these questions. The privacy policies will often say that data will be shared with third parties, and then third parties have their own privacy policies, which you can go read. So let's look at this one from Musical.ly. So in the privacy policy, it says all about the third parties. We share your information with the following selected third parties. We're told that there are business partners, advertisers and advertising networks, cloud storage providers. Of course, none of the third parties are actually named. Why would they? There's no legal requirement to. So neither under GDPR or the soon-to-go-into-effect California law, companies can list the exact third parties, or they can list categories of third parties, which is what we saw in that policy. So unless you're actually decompiling the app or doing traffic inspection after you've already run the app, there's no way of knowing the privacy policies of the third parties that are receiving your data. So there's no way of getting from A to B. So to fill in, some of the issues with having to read privacy policies, the platforms have provided various privacy interfaces that are to help users. So my group did some work on this about 7 years ago when, at the time, Android had these install time prompts. These are useful because they tell you the abilities that an application may exercise in the future, but the problem is this is done at install time, so it's possible that the features that use these abilities may never get executed. It's also possible that the apps are over-provisioned, so maybe the location data is never actually collected and it was an error by the developer putting that in the manifest file. Or it's possible that by putting the location data here, users might think that they're agreeing to location-based features which they might find desirable, but in fact it's actually only used for location-based tracking, which they find undesirable. And so the problem is there's no real context as to how this data is going to be used. So based on this, both platforms have improved. We now have what we call ask on first use prompts. So the first time an application accesses one of several different types of sensitive data, the user is prompted. They can then allow or deny the request. And that the choice that they make there to allow or deny it takes effect essentially in perpetuity, or at least until they go through several layers of settings to reverse that decision. And the problem with this, like the previous set of privacy UI components, is it just completely ignores context. So the first time the user is prompted, it might be because they clicked a button in the app to find something near them, and that's a feature that they might desire. But now that the app has been granted access to the location data, they're never going to be prompted again, and so it might start using location data for things that they find undesirable. So we decided to study this, and what we did is we wanted to perform dynamic analysis to examine how often these resources are actually used in practice by apps that people actually use. And so what we did was we hooked all of the API methods that are protected by the Android permission system and then gave those modified phones to 40 people. 36 of them returned them. And what we found is that a lot of the access to sensitive data on these devices is actually very opaque, which is not really a surprise to anyone in this room, I assume. So 75% of the time when sensitive data protected by the permission system is accessed, the user's not actually using the app that's accessing the data. So often this is because the service is running in the background, but the majority of the time, so 60% of the time, they're not even using the phone when the data is being accessed. And this stands in contrast to another study that we did earlier where we asked people what they believe happens to an app when it's no longer running in the foreground. And in fact, only a little over 20% of our survey respondents understood that apps running in the background have the same abilities as apps running in the foreground. Most people believe that when the app goes into the background, it either stops running entirely or it's limited in what data it can access. That's obviously incorrect. Another thing we found is that the other privacy indicator that exists on the platform isn't very useful. So both iOS and Android have a location indicator, which is illuminated in the status bar whenever an application tries to access the GPS hardware. Unfortunately, on Android, there are actually 3 different ways, at least 3 different other ways of accessing location data. So apps can query cell tower data, they can look at Wi-Fi hotspot information, and they can also look at the location cache. So whenever an app does access GPS hardware, that's cached and is accessible to any other app on the device that has access to the location permission. And so what we find is that in 99.96% of the time when apps access location data, they're using one of these other APIs, which means that this indicator never appears in those cases. And so people might interpret this indicator as meaning when the indicator isn't there, apps aren't accessing location data, but that's absolutely not true. So this is all about data that's protected by the permission system. What about sensitive data that's not? And by that, I primarily mean persistent identifiers, which are kind of the bread and butter of the tracking industry. So both Android and iOS have what's called the advertising ID. And this was created so that it's a user resettable identifier that users can periodically reset, similar to clearing your cookies in the browser if you want to not be tracked anymore. So let's see what happens. If you click the opt-out of ads personalization because you want to disable behavioral advertising, what do you think happens? So here's an example of an ad request from an actual app. In red, we have locations coordinates are being transmitted. In brown, it's that advertising ID. And then we have this flag that says DNT equals 0. So if you opt out of tracking, what do you think is going to happen in terms of what gets transmitted? So everything except DNT becomes 1. And so essentially all of the third parties are receiving the same personal data from the apps, but are then told to please ignore all of this data that we're sending you. And that's somehow they're accountable for that? I don't know. I don't understand how that works exactly. So given all this, how can users actually make informed decisions about their privacy? So to solve this problem, we combined the instrumented Android fork that we had been working on, which monitors all of the sensitive APIs, and we combined that with network monitoring code. So a separate project going on at ICSI is called Lumen, and it's a traffic analyzer that runs in user space on Android, intercepts TLS payloads, and so we have a pretty good view into everything. And so combining these tools, we've built this whole dynamic analysis pipeline. So we're mining Android APKs. We have a repository of about 120,000 that we've been keeping track of for about 2 years now, so we get new versions as they're released, so we can do longitudinal studies. We then push these to our test bed of instrumented phones, and then we simulate user interactions. How do we simulate user interactions? We use the exerciser monkey. So the exerciser monkey is basically, it fuzzes the UI. It actually comes with the Android developer tools, and it's intended for debugging the UI by sending random clicks, swipes, button presses, that sort of thing. We did an experiment where we had a student play 500 games for 10 minutes each, and we had the monkey run the same games for 10 minutes each. And what we found was that we got over 60% overlap in code coverage. Well, sorry, for 60%, more than 60% of the apps, we had identical code coverage between the student playing the games and the monkey. So this is a reasonable choice for doing this at scale. We basically have a click farm that's running in the office with lots of phones chained together, and they constantly push new apps. And then in the outgoing traffic, we look for various types of identifiers. So there's outright personal information, like the device's owner, email address, phone number, various other data points that can be used to infer location. But then there's also a whole slew of persistent identifiers that we look for. And all of this is available online. You can go to our website, appcensus.mobi, and search for apps in the Play Store. And if we've analyzed them, you can see what data they access and with whom they share it. And so to give you an idea of some of the things that we're looking at and that we found from this, there's a whole spectrum. And on one end of the spectrum, there's outright deceptive practices, which are pretty alarming. So here's one example. So you would expect that these two sets are disjoint, so the apps that don't have location permissions, then the apps that are transmitting location data. That seems a reasonable assumption, but we can query our database to check this in practice. And what we find is that there are about 1,300 apps in our data set that don't have the location permission, yet are transmitting street-level location data. And so at this point, this is when we start disassembling apps to try and figure out how it's possible that they're getting this location data, and that led to this. So here's an example. This might be hard to read. This is a disassembled add SDK. It calls the Android API is permission granted for access Wi-Fi state. That's the permission that protects information about the Wi-Fi hotspot, which then could be used to infer the user's location. If Wi-Fi state was not granted, it jumps to calling get device MAC address from ARP. What does that do? Why, it opens the proc file system and just reads the ARP table directly from there. And so you would think that they shouldn't be able to use the file system to circumvent the Android permission system, but this is not the case. And in fact, we've seen hundreds of apps that are actively exploiting this vulnerability, as well as several others that we've documented. So we reported this to Google. Google gave us a bounty. They said they're fixing it. I don't know what they're doing, but maybe we'll hear more. Multiple SDKs are exploiting this vulnerability, and this impacts hundreds of apps, including kids apps, which I'm going to talk about a little later. Another thing that we see is misuse of persistent identifiers. So as I mentioned, both platforms have this advertising ID, and the whole point of the advertising ID is giving users a resettable ad ID so that if they want to stop being tracked, they can just reset that ID and start over. Of course, this doesn't work if the advertising ID is associated with other persistent identifiers which the user is not able to reset. And in fact, both the Google policies and Apple policies account for this. So here's from the Developer Policy Center, the policy on using the ad ID, and it says that the advertising identifier must not be connected to personally identifiable information or associated with any persistent device identifier without explicit consent of the user. We've never seen a screen asking for explicit consent to do this, yet we find that of the apps that transmit the advertising ID, 2/3 of them are transmitting it alongside non-resettable identifiers, therefore negating any privacy-preserving properties of the ad ID. Of course, most of this seems to be due to the use of third-party code. So there are a lot of ad SDKs that appear to be violating this policy. So one end of the spectrum, we have Chartboost, which in our data set is almost uniformly violating this. Greedy Game is another, Tapjoy. At the bottom, DoubleClick, only 1% of the apps using DoubleClick are violating this, which I guess is good until you can consider the fact that DoubleClick is a property owned by Google. So you would think that those creating the policies to use the platform, those policies would be followed by other divisions of that same platform. That, in fact, is not the case. We've reported, so we reported about 4 months ago about 17,000 apps that were violating this policy to Google, including a list of all the advertisers receiving the data. And in response, we were told that we need to definitively prove that the identifiers are being used internally for behavioral advertising. My response back was, one, that's not what the policy says. It's the collection that's the issue. And two, they know as well as we do that we have no insight into what the company does internally with that data. And that's where this was left 4 months ago. Another thing that we've looked at is insecure transmissions, as well as what promises are made about secure transmissions and privacy policies. So going back to picking on Musical.ly again, here it says we do our best to protect your information, for example, by encryption. But in our data set, I guess their best isn't good enough because multiple persistent identifiers are set alongside are all sent without TLS. And again, I'm picking on this just because it's a popular app, but this seems to be a representative practice. So of 42,000 apps that we found transmitting personal information in our data set, about half of them are doing so without TLS. It's 2019. There's not really a good excuse for that. And this all, goes back to this issue of these privacy issues coming from the inclusion of third-party services. And here's an example of that. So here was another app that we identified early on. Here's a traffic dump in yellow. We have communication on, port 80 to talkingdata.net, which is a analytics company in China. They're receiving in blue here. This is pretty much all the identifiers associated with the device. So IMEI, Android ID, advertising ID. In green, we have our Wi-Fi hotspot and its MAC address, which is used to infer location. And so out of curiosity, we notified the developer and we asked if they were aware of all of this data that was flowing to Talking Data. And a week later, they actually responded to us and said, thank you for pointing this out. We've removed that SDK. And we actually checked, and all of their apps had been updated in the Play Store, and the SDK was removed. So, this suggests that, some developers, and I suspect most, just simply aren't aware of what the third-party code in their apps is actually doing. But nonetheless, they're responsible for it. And, while making promises in the privacy policy, which may or may not be true, seems to be a pretty regular occurrence, and so it's not clear what enforcement mechanisms are going to scale in that case. There's also limited federal legislation which governs some of these practices, which developers should also be very concerned about. So in the US, while we don't have any comprehensive privacy legislation, the closest thing we have is the Children's Online Privacy Protection Act, which governs data collected from children under 13. And so it prohibits collection of personal information, performing behavioral advertising without verifiable parental consent. And it also requires reasonable security measures. So as a test case, we decided to look at just child-directed apps to see how well these apps are complying with this one law. And in fact, what we find is that potential violations seem to be rampant. So, the cases where they're outright collecting personal information, like the name and phone number associated with the device, is relatively rare. It's about 5% of the apps that we examined. But then you have other things like the violation of the advertising ID policy, about 40% of the time that occurs. Use of non-compliant services, which I mean services that say that they do behavioral advertising and therefore shouldn't be put in children's apps. And then 40% of the apps are transmitting this data without TLS. So looking at some of these services, to their credit, they have terms of service geared towards developers that say, don't use this code in children's apps. So here's an example, MoPub, which is an advertising network owned by Twitter. It says that you will not transmit any personal information, as defined under COPPA, about or relating to an individual under the age of 13 to MoPub. Reading these terms of service, you might wonder why they have this clause there. You read the privacy policy, and it's because they're using that data for behavioral advertising, which, if done in children's apps, would violate federal law. So nonetheless, MoPub seems to be in a lot of children's apps, and here's an example of some traffic. So again, going over port 80 as part of an ad load here. But it's also reporting the name of the app that's receiving the data. So, we can look up the app in the Play Store with all this information, and we can see that this is targeted at children ages 8 and under. So, MoPub clearly has the same information that I do. They could cut the app off and not pay them the ad revenue. But they don't. Instead, we found it in about 164 kids apps. But again, this I'm citing one example, but these practices seem to be pretty uniform across the industry. And so the whole point about this talk is that app developers, SDKs, and platforms all need to do things to do better here. There's the problem of users not having the tools to make informed decisions about their privacy, and maybe as a developer you don't really care about that, but someone who does care are regulators. And actually regulators have now been using the data on our website to file suit against various companies that are making misrepresentations about the privacy practices of their apps. So this one was filed, I think, 3 weeks ago, and it was someone messaged me a link to this. I had no idea that they had been using our data, but in the complaint there was the link to our website, which is kind of cool. So closing recommendations. App developers really need to know what their apps do. If you're using third-party SDK code, you should figure out what that code is actually doing in your app and what it's sending to those third-party services. Platforms should offer more usable privacy controls so that users can actually make informed decisions and have better insight into what the apps they use do. And then both SDKs and platforms need to proactively enforce policies. Both the platform and the SDKs have these policies about what is acceptable and not, but they don't seem to be enforced at all. And so, if everyone does this stuff correctly, what about users? Well, what should users really do? If all of this stuff is working correctly, I would argue users shouldn't be expected to really do much more. And I'll leave it at that.